oXYchrome.
This is oXYchrome by Elemental Devices. It is a multidimensional performance controller for Eurorack systems. After about a month of research, the project began with creating various mock-ups, first with paper cutouts, then digitally, until I landed on a final design. Once the 3 capacitive touch sensors arrived, I set up the Arduino environment and started testing everything out. Around the same time, I built a cardboard model, which I used as a starting point for 3D modeling a 2-part enclosure in Fusion 360. In an iterative design process, I printed multiple prototypes of the case and lid, tested them out, and subsequently adjusted the models until I arrived at a snug and flush fit of all components. Meanwhile, as the rest of the parts arrived, I constructed more elaborate breadboard prototypes, testing out the different features and getting everything to work together. Now it was time to start assembling the controller. I ended up switching over to an Arduino Nano so I could fit everything on a single piece of stripboard. I soldered the microcontroller, multiplexer, and DACs to the board, and wires connect to the sensors and output jacks in the lid. After adding thread inserts and some other finishing touches to the enclosure, the last step left was laser cutting a piece of acrylic to diffuse the LEDs. Once this was glued in place and the code completed, oXYchrome was finished. But now, let's get to patching. Central to the controller is a ring-shaped sensor that outputs control voltage for the position and a gate when touched. The 2 square sensors to the left and right of it send out their X and Y position as well as the amount of surface covered by your finger. Here, the ring sensor is controlling the main cutoff of a filter, while X and Y position determine an offset for the left and right channels. The Z or pressure output is controlling the resonance of the filter. With the right square, I am manipulating a delay effect. Instead of an audio source, I am now using a simple gate signal as the input to the filter. When the resonance is set high enough, the filter will become an oscillator, and the cutoff is controlling its pitch. Next, I'm going to use the ring sensor to play a synth voice. The position output is going through a quantizer and into the volt per octave input of the synth. The gate is triggering the envelope. Additionally, the left square is controlling the parameters of the wave folder.
oXYchrome.  2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2
That's it for my explanation and demonstration of oXYchrome. I hope you liked it. Thanks for watching.
oXYchrome.